You have trained a binary classification model and are using the Fairlearn library to evaluate its fairness. You are looking for a way to mitigate fairness issues without performing any additional model training. Which Fairlearn tool is appropriate for this requirement? The options are Option A, Fairlearn.reductions.exponentiated gradient. Option B, Fairlearn.preprocessing.correlation remover. Option C, Fairlearn.reductions.grid-search. Option D, Fairlearn.postprocessing.threshold optimizer. If you've identified a biased model produced by feature A, the appropriate strategy for reducing performance bias without performing any additional model training is to use a post-processing remediation technique. Fairlearn.postprocessing.threshold optimizer falls into this category. Option A, Fairlearn.reductions.exponentiated gradient is an iterative algorithm for training a conditional biased classifier, but also involves training several base classifiers. Option B, Fairlearn.preprocessing.correlation remover is a pre-processing technique, so while Robert is several choices of post-processing, it is not realistic. Option C, Fairlearn.reductions.grid-search is an iterative algorithm for training a conditional biased classifier, but also involves training several base classifiers. Option D, Fairlearn.preprocessing.threshold optimizer is a post-processing technique, so while Robert is several choices of post-processing, it is not realistic. Option C, Fairlearn.reductions.grid-search is an iterative algorithm for training a conditional biased classifier, but also involves training several base classifiers. Option D, Fairlearn.preprocessing.correlation remover is a pre-processing technique, so while Robert is several choices of post-processing, it is not realistic. Option D,
The core concept here is fairness mitigation in machine learning. Fairness tools generally operate at different stages of the machine learning pipeline, such as before training starts, during the training process, or after the model has already been finalized. The goal is to determine which specific category of mitigation techniques allows for adjusting predictions while leaving the existing, already trained model intact. I believe the correct answer is option D, Fairlearn.postprocessing.threshold optimizer. Fairlearn categorizes mitigation strategies into pre-processing, reductions, and post-processing. Post-processing is the key here, as it allows us to adjust predictions after the model is trained by modifying decision thresholds based on sensitive attributes. Threshold Optimizer is specifically designed for this, meaning it avoids the need for retraining. The other options are incorrect because they require retraining. Exponentiated gradient and grid search are reduction-based approaches that must be applied during the training phase. Similarly, correlation remover is a pre-processing technique, so it would require you to modify your input data and then retrain your model from scratch. For your exam, remember that post-processing is the only category that keeps your base model unchanged.